All right, let's have the following exploratory problems on work and energy. Okay, so number one, what is the work done by a man whose weight is 90.0 kilograms and climbing a 15-meter pole? Okay, so the formula for work is equal to F multiplied by the displacement. Actually, this one, 90.0 kilograms, this is the mass of the person. So we have to make a conversion here. Okay, so 90 kilograms multiplied by 9.8, this will give us 882 newtons. That is the FW. That's the weight of the person, 882 newtons. And the displacement is 15 meters. So we multiply this by 15 meters. What do we get? So 882 times 15 meters, you will get 13,230 Newton meter or joules. Okay, we round this off to two significant figures. We get 13,000 joules. Okay, so in kilojoules, this would just be 13 kilojoules. Okay, but the problem is just not asking specifically for the unit, so we can have this as our final answer. Okay, number two, a person pulls an 80-kilogram crate 20 meters across the floor using a rope that is 30.0 meters, 30.0 degrees above the horizontal. Okay, so let us illustrate this. This is 30 degrees. The displacement is 20.0 meters. The mass of the crate is 80.0 kilograms. Okay, the question, the person exerts a force of 150 newtons on the rope. So F is equal to 150 newtons. Okay, it's this F here. Okay. How much work is done? So we need to get F sub X. Okay, the F sub X is 150 newtons. It should be parallel to the floor, therefore 150 cosine 30 degrees. Okay, so to get the work, we have W is equal to Fx times the displacement. Okay, so the Fx here is 150 times cos 30. This gives us 129.90. So 129.90 newtons multiplied by 20.0 meters. Okay, so times 20. This gives us 2,598 Newton meter or joules. So we follow 2SF. Okay, this gives us 2,600 joules. So we don't need this data, the mass of the box. Okay, so because we need just the force and the displacement. Let's go to number three. A 50.0 kilogram box is pushed across a horizontal floor with a force of 250 newtons. The coefficient of kinetic friction is zero point 0.4. Find the work done in pushing the box 20 meters. Okay, let us illustrate this. You have here the box. There is a force of 250 newtons. The mu k is 0.40. Uh, okay, find the work done in pushing the box 20 meters. Okay, so the displacement is given 20 meters for letter A. So work is equal to F times the displacement. The force you exerted is 250 newtons, and then the displacement is 20 meters. This should give us 250 times 20. You get 5,000 joules. Okay. But there's a follow-up question in letter B. how much work went into overcoming friction and how much work went into accelerating the box. Okay, so let us find this out. Okay, so for the friction, we have to compute for the frictional force. No? We use uh, sum of forces along the x. What are the forces along the x? You have the applied force. Okay, you have F, the one that is applied, that's positive, minus FF. Then this one is mass multiplied by the acceleration. Okay. Uh, so sum of Fx, we need to get this one. No? Uh, how do we find FF? FF is mu Fn. So FF is equal to mu Fn. The coefficient of kinetic friction is given 0.4 multiplied by the normal force. How do we get the normal force? This one, the 50 kilogram box. Okay, 50 times 9.8, we have to get the weight of this box. It's 490 newtons. If this is the FW, this is negative, then F sub n should be positive, 490 newtons. Okay, so the FF is 490 times zero point 0.4. This will give us 196 newtons. Okay, so 196 newtons here is opposite the direction. So we have to find the work that went into friction. So work friction is 196 newtons. This is negative multiplied by the displacement of 20 meters. Okay, we get negative 3,920 joules. Okay, so this is negative because the direction of the force and the displacement, they are opposite. No? Uh, then the force that you supplied is 5,000 joules. So the sum of Fx is 5,000 joules minus 3,920. Okay, this would give us a net force that is 5,000 minus 3,920. A net force equal to 1,080. Uh, oops, sorry. This should be, oops, sorry. Let me erase this. We're talking about newtons, no? So we have to use 250 newtons. Okay, so 250 newtons. So the F that we are looking, we have to substitute is 250. So 250 newtons minus 196 newtons. Okay, so what went to accelerate is just 54 newtons. Okay, so 54 newtons of force went to accelerate the 50 kilogram box. So the question, how much work went into overcoming friction? It is this answer. Okay, negative, let's express this in 2SF, negative 3,900 joules. And how much went to accelerating? So work is equal to the force that you supplied for to accelerate is 54 newtons multiplied by the displacement is given 20 meters. Okay, so 54 times 20 is 1080 joules. Okay, actually, this is the difference between 5,000 and 3,920. Okay, let's go to problem number 4. In problem number 4, a 150-pound box is pushed across a horizontal floor with a force of 65 pounds. The coefficient of kinetic friction is zero point 0.4. Letter A, find the work done in pushing the box 65 feet. Now, problem 4 is similar to problem number 3, but this time we are using the English system. Okay, so let us find the work. So work here is equal to F times D. The force that you supplied is 65 pounds multiplied by uh, the displacement, which is 65 feet. Okay, so 65 times 65. This will give us 4,225 pound-feet. Okay, so there is no special term for the unit of work in the English system, so we just leave it as pound-foot. It's understood that that is the unit for work. Letter B, how much work went into overcoming friction and how much work went into accelerating the box? Okay, so we compute for the FF. The FF is mu Fn. Okay, the mu is zero point 0.4 and the normal force is 150 pounds because this one is already the weight of the object. So zero point 0.4 times 150. This will give us the frictional force is 60 pounds. So we can readily compute for the work that went into overcoming friction. It's going to be 60 pounds of force multiplied by 65 feet. Okay, this would be 3,900 pound-feet. So a while ago, we were able to compute for the work that went into acceleration, okay, by subtracting, okay, 4,225 and 39. Okay, this is from here, no, from the previous problem. If you subtract 5,000 joules with 3,920, you will get 1,080. So we can do that directly without going through this equation anymore. That's our shortcut. Okay, so WA is equal to 4,225 pound-feet minus 3,900 pound-feet. Okay, we are going to get 325 pound-feet. Okay, so let us check the number of significant digits. It should be 2. So this becomes 4,200 pound-feet. This is okay. And this one is 330, oops, 330 pound-feet. Let's go to problem number 5. A 25 kilogram ball fall freely through a height of 303.0 meters. This one should be a height of. Okay, find its kinetic energy in joules when it hits the ground and show that the kinetic energy gained by the ball is equal to its potential energy before falling. So let's compute for the potential energy initially when the ball is at rest up there. Okay, so the mass is 25 kilograms. The G is 9.8 meters per second squared, and the height is 3.0 meters. Okay, so what do we get? What is the times 9.8 times 3.0? Get 735 joules. Okay, so up here, say the ball was thrown from the top. Up here, the potential energy is 735 joules. Now, since this is at rest, 735 joules is equal to the total mechanical energy, okay, of the entire system. When the ball goes down, it reaches the ground, okay, it would gain speed. So sabi niya, find its kinetic energy in joules when it hits the ground. So this is, we have near the ground, the potential energy is now equal to 0. Therefore, uh, the kinetic energy is now 735 joules because we have the statement from before. The TME is equal to a constant, and the TME is just PE plus KE. Okay, so it says here find its kinetic energy. So whatever is the potential energy up here, has already transformed into kinetic energy. Naging kinetic energy na siya. Show the KE gained by the ball is equal to its potential energy before falling. Okay, using this equation, okay, TME is equal to a constant. So down here, the TME is just purely kinetic energy. Okay, and up here, the TME is 735. So the TME here is also 735 joules. Okay, so that would be our proof. Let's go to problem number 6. Under the action of certain forces, a drum of liquid detergent moves up a 30-degree inclined plane to the delivery truck. Okay, let us draw this. Okay, let's say this is the drum. Okay, the weight W is equal to 180 newtons. That is the weight downward, FW. Okay, so FW is 180 newtons. The normal force, okay, this one, F, is 156 newtons. A force F is used to push the drum up, this F here. Determine the work done by each of the three forces when the drum moves 4.0 meters along the inclined plane surface. So na-display siya ng 4.0 meters. So the D is 4.0 meters. Now, it says here three forces. Let us take a look at Fn first. Fn is the normal force. It is perpendicular uh, to the direction of the movement, which is 4.0 meters. Therefore, with respect to the normal force, the work is equal to 0 because it is not in the same direction. They are perpendicular. Fn is equal to 0. So what matters here would be the work done by this F and by this FW. But for the FW, we have to look for FWX. Okay, and how do we find the FWX on an inclined plane? We multiply this by sine of whatever the degree is. So 180 newtons sine 30 degrees. Sine 30 is a half of it, so 90 newtons lang yung FWX. So the FWX is always headed downward, so this is opposite the direction. So the work that is done by the weight of the object, okay, by FWX, let's write it here, is equal to negative 90 multiplied by the displacement of 4.0 meters. Okay, this will give us negative 360 joules. Okay, that is because of the weight of the object. Now, what about this F? Okay, it says here the normal force. Determine the work done by each of the three forces. Not given yung F neto, no? This one, let's say that this is moving up at constant speed, then the F here, okay, should also be equal to the WFX, okay? Assuming that there is no frictional force. Wala siyang sinabi na may frictional force, eh, no? So the F and this F, they are equal. So you have to supply a force of 90 newtons, okay? Just so you can move the object at constant speed. Okay, so W is equal to ito naman multiplied by 4.0 meters. This is W is equal to F times D or D times F. Okay, so 360 joules. Okay, let me just check this. Okay, let's go to problem 7. Find the potential energy gained by a 50,000 kilogram train after climbing a 20-meter hill. So this should be an easy problem. PE is equal to mgh. The mass of the train is 50,000 kilograms. The G is 9.8 meters per second squared, and the height of the hill 20.0 meters. Okay, so we just multiply 50,000 times 9.8 times 20. This gives us, okay, 9, 8, then followed by 1, 2, 3, 4, 5. Okay, so this is 9,800,000 joules. Okay, uh, let's go to the last number, number 8. A bullet moves with a velocity of 600.0 meters per second. This is the speed, okay, v, and has gained a kinetic energy of 900 joules. So Ke is equal to 900.0 joules. Compute its mass. So we know that Ke is equal to 1 half mv squared. So we leave this to one side of the equation. V is equal to 2 Ke over m, then square root. Okay, so you have 2 times 900 joules, 900.0 joules divided by the mass. Okay, sorry, divided by, velocity pala, no? Ang hinahanap. So we leave m here. Okay, sorry. We leave m here. Ito yung v. Oops, wait, let me just correct this. Sorry for this. Erase ko lang. Erase ko everything. Erase. So we're looking for the mass. So dapat yung v squared lilipat. Okay. So m. Oh, it's not writing. What happened to the ball pen? Let me just pause this for a while. Okay, so m is equal to 2ke over v squared. Okay, so twice the kinetic energy divided by 600.0. Then we have to square this. Okay, so 2 times 900 divided by 600 squared. Okay, the mass that we get is very small, 0.005 kilograms. Okay, so or just 5 grams. Very light naman yung bullet. Okay, so thank you.